2x over x squared plus 8 dx, and we have n equals 5. Okay, good. So the interval between 1 and 2 has to be split into 5. So then delta x is 2 minus 1, which is 1 over 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is 1 plus 1/5. So 1 plus 1/5 is 6/5. 6/5 plus 1/5, 7/5. 7/5 plus 1/5, 8/5. And 8/5 plus 1/5, 9/5. And 9/5 plus 1/5 is 10/5, which is 2. But now they're asking us to find the midpoint. So that's the biggie, right? So 1/5 divided by 2 is 1 over 10. So this piece is 1 over 10. This piece is 6/5 plus 1 over 10. This one is 7/5 plus 1/10. This one is 8/5 plus 1/10, and this last one is 9/5 plus 1/10. So I need to calculate all these. So the first one, so this will be approximately delta x f of 1/10 plus f of, so this is 2, 16 plus 1, 13/10 plus f of 14 plus 1, 15/10 plus f of 17, of course, 10th plus, so we have 5 subintervals, 1, 2, 3, 4. I need one more. Yes, 9/5 plus, so this is 18/19. At this point, I can't do any of this. I need to put in the calculator. So go back to lists, edit, clear. I enter 1 over 10.1. I enter 13 over 10, 1.3, and then 1.5, and then 1.7, and 1.9. And enter. I go back, highlight L2. In front I have 0.2, left parenthesis. And now the function is x over x squared plus 8. So careful here. We have L1 divided by, parentheses mandatory, L1 squared, and then plus 8. Close and close again. So when we enter and I click enter, I get all these amounts. Then I go to second and quit. I go to stats. I want to calculate this time, and it's a one variable stats in list L2. And I calculate and I get 0.122548667. Any questions? So the most cumbersome part of all this was to find the midpoints, to establish the boundaries of each subinterval, and then identify the midpoint for each. Was this okay?
Yes, that makes perfect sense. Thank you.
Thank you. Awesome. Okay, so in order to complete 5.3 now, I'm on page 4. So again, 5.1, 5.2, and we're looking at 5.3. In 5.3, we only need to go back to the fundamental theorem of calculus, part 1 and part 2. This was done. The function must be continuous, and then the integral from a to b from f of x dx is the antiderivative from a to b, which means uppercase f of b minus uppercase f of a. And this is part 2. What does fundamental theorem of calculus part 2 teach us? What does it teach us? It teaches us how to evaluate a definite integral. Okay, so part 2 shows how to evaluate a definite integral for continuous functions. So this is what it does, part 2. Now the question is, what about part 1? I do have a basically 1-minute discussion for you today, but allow me to change the 1 second. I would like to change the starting point before it's due. I don't know if it's my internet or Canvas is slow. I clicked on modules. Okay, almost there. I'm trying to edit it. Okay, I'm editing, so the time. Okay, so that's out of the way. Good. So now let's talk about part 1. This is very clear. Part 2 is teaching us how to determine a definite integral, how to evaluate it. But what about part 1? Okay, part 1 teaches us or shows that differentiation and integration are inverse operations. So it shows that differentiation and integration are inverse operations. What does that mean? Well, when we differentiate, let me just give you examples here. Easier to see. So if I have a derivative and I integrate the derivative, I will get the function. Because this symbol and this symbol cancel each other out. Now, if I have an integral and I differentiate the integral, I also get the function back because this operation cancels this operation. It's like when we take the square root from x squared. Well, there are some issues there because we get the absolute value of x and so on and so forth. But this operation cancels this operation or vice versa. I can do x, the square root of x, and then squared. Same thing. They are canceling each other out. Same thing here. So part 1 says that differentiation and integration are inverse operations. When I integrate a derivative, I get the function. When I differentiate an integral, I get the function. But there is a step here that we need to look at. So how do we illustrate this in general? How to present this topic? Well, what we are going to do is we are going to present or have a function, g of x, in a form of an integral from a to x from f of t dt. So before you look at this, don't even look at it right now. I just want to show one thing. So let's take a look at this function. We have a function f of t, t and y, of course. And I have the interval, our best friend, always, the interval a to b. And can anyone tell us what this equals to, this area? How do we express this area? Is there a way of expressing that area from what we studied so far?
The total for whatever the function is. Or that
yes,
area.
how do I write it? Yes.
I don't know.
The integral from, of course, this is t, so I'm going to use t. So this area is nothing else but the definite integral from a to b from f of t dt. Now, what if I have x here? Can anyone give us this area?
Same, just a to x.
Exactly. So this area now, this is big A, I'm gonna call this A1 because it's just this piece. It will be from a to x from f of t dt. But what if x is here? I will have a bigger area. What if x is here? Well, I will have a different area. What if x is here? Well, I have a different area. So what am I really telling you is that because this can be any number between a and b, then we're just creating a function. So this is a function given as an integral. Because if I have x, which is a, then I get 0. If I have x here, then I get 10. If I get x here, then this will be 15. If I get x here, then this integral will be 25. I'm just picking up numbers, right? So this is a function, and that's what we have here. So this is a function given in a form of an integral. Again, if x is a, then this integral is 0. If x is 1, then I'll get a number. If x is 2, I'll get another number. If x is 3, I get another number. So this is a function. This function is g of x given in the form of an integral, and it depends on x. So how do I use this and the fact that differentiation and integration are inverse operations? Very simple. And this is the last topic in 5.3, and then we can move on. So again, g of x equals the integral from a to x from f of t dt. We are never going to be asked, nobody is going to ask us to evaluate. No, no evaluate. No. The only thing we can be asked to find is find g prime of x. We cannot evaluate. This is a function. Unless I give you x, you can never evaluate it. So then what are we going to do is simply differentiate both sides. So I'm going to differentiate this, and I'm going to differentiate this. The left-hand side will be g prime. Can anyone give an idea of what this will be? Remember, this symbol cancels this symbol, and obviously this symbol as well.
Isn't that just f of x then?
Exactly. Exactly. That's it. That's all we're going to do. But of course, there are different situations Some of them are more cumbersome than others. So let's look at a few examples. Allow me to choose the first one, and then you choose the next one. Okay. Use part 1 of FTC to find the derivative. The derivative, we're not asked to integrate. To find the derivative of the function. So I would like to choose, let's start simple first. Okay, I would like to start with 9. And you'll see why I'm starting with 9 in a minute. So we have g of x equals the integral from 0 to x from the square root of t plus 3 cubed plus t cubed dt, the square root. Okay, perfect. Whenever we are asked, we are given a function as an integral, and we are asked, of course, to differentiate, we have to make sure first that the lower limit is a number, any number. Notice that this number was not even discussed, right? It doesn't matter what it is, but it has to be a number. And the upper limit has to be x or a function of x. And I'll show you what happens when it's a function of x. Well, here I should write times x prime. But why didn't we write x prime? Is anyone with me?
Because it's 1.
Because it's 1. So all we need to do is just differentiate. So if we differentiate, the left-hand side will be g prime of x, and the right-hand side is f of x. That's all I need to do. This is it. I should write times x prime, but it's 1, so there is no need. So let's stop and do that 30-second